Hi friends, welcome to the channel. Let's continue our journey of Spring Data JPA. If you are watched the previous tutorial, you might have good understanding of entity. If you missed that, you can check it from here. I also provided the link in the description. In this video, I'll focus on repository. I will discuss about repository pattern, how to define custom query methods in your repository, and how to define your own queries. Hopefully, it will be helpful for you. So, without further delay, let's get started. Let's talk about a repository pattern. It's a design pattern that connects the data access and business logic in our application. By using this pattern, we can abstract a data layer, providing more object-oriented way to access data. In Spring, we use repository interface to interact with the database, leveraging the powerful feature of Spring Data JPA. At its core, the repository pattern acts as a bridge between your application's business logic and data storage. It encapsulates data access logic within repositories which are responsible for querying and manipulating data from the underlying data source, like database or web service. By doing this, it shields our application from the complexities of data storage. This makes it easier to switch between data access to make changes to the database schema without affecting our application's code. The repository interacts with data mappers and query objects to perform operations like retrieving and saving data. Even though this might seem like overkill for our simple app, using the repository pattern provides a protective layer that ensures our application can scale effectively and handle more complex scenarios in the future. The repository pattern allows our business logic to query and persist data without needing to know the details of the underlying database operations. It promotes cleaner and more manageable code. In the past, creating a data access layer for an application was difficult because it requires writing a lot of repetitive code. Domain classes are often simple and not designed to fully object-oriented or domain-driven principles. The goal of Spring Data's repository system is to make it much easier to create the data access layer for different types of database. In this section, we learn the main ideas and interfaces of Spring Data repositories. Let's start by creating a repository interface. Open the sidebar and go to src, main, Java. In our root package, create a new Java class, but make sure to select interface instead of class. I will name this interface employee repository. This interface will extend JPA repository. Make sure to import it from org.springframework.data JPA repository. The JPA repository is a core interface that provides built-in methods to work with JPA entities. It makes it easy to perform database operations using JPA. It's a generic interface, so we need to specify two things. The entity class we want to manage, in this case, employee. The data type of the entity is primary key. For employee, the primary key is ID, which is type of long. Now, our employee repository is ready. Let's look deeper into what JPA repository does. If we Command plus click on Mac or Control plus click on Windows on JPA repository, it will open the source code for the interface. You can see that JPA repository extends three other interfaces: list CRUD repository, list paging and sorting repository, and query by example executor. For now, let's focus on list CRUD repository and list paging and sorting repository. Click on list CRUD repository to see its source code. List CRUD repository extends CRUD repository. If we check the CRUD repository source code, you will see that it extends another interface called repository. The repository interface does not define any methods. It acts as marker interface and helps Spring Data discover and manage your repositories. When Spring scans your application, it looks for interfaces that extend repository. Then, based on your method names and parameters, Spring automatically creates the implementation for these repositories. Now, let's look at CRUD repository. The CRUD repository interface provides methods for basic create, read, update, and delete operations. It saves time by letting you interact with the database without writing a lot of code. Some important method provided by CRUD repository includes save. This saves an entity to the database. If it already exists, it updates the entity. Then we have save all, save a collection of entities. Find by ID retrieves an entity by its ID. Find all retrieves all entities. Delete by ID deletes an entity by its ID. And delete deletes the given entity. There are more methods available. Feel free to explore them. Now let's talk about list CRUD repository. This interface extends CRUD repository but has one key difference. Instead of returning iterable for methods that retrieves the multiple entities, it returns a list. For example, the findAll method in CRUD repository returns an iterable, but this list CRUD repository, it returns a list. Using a list is more convenient because you can directly access elements by index and use methods like get, indexOf, or sublist without converting the result. Finally, let's go back to JPA repository. The JPA repository also extends list, paging, and sorting repository, which in turn extends paging and sorting repository. This paging and sorting repository also extends the repository interface. The paging and sorting repository provides method to work with the paginated and sorted data. This is useful when dealing with large dataset. That's it for now. With this, we have explored the basics of JPA repository and its related interface. Next, we'll focus on using repositories in our project. At this point, we have set up our employee entity, created a database table with all the necessary columns, and defined a repository for employee. Now, let's perform some database operations. In real-world application, we typically have controllers and service layers. The controller handles HTTP request and calls the service layer to process the request. The service layer then performs any necessary calculations and interacts with the repository to handle database operations. For example, if we wanted to handle CRUD operations, we would define endpoint in the controller for creating, reading, updating, and deleting data. The controller would call the relevant service method and the service would use the repository to work with the database. But since this tutorial focuses on Spring Data JPA, we will skip this part. Instead, we will use command line runner to perform database operations. Now, what is a command line runner? It's a special tool provided by Spring Boot that allows us to run code immediately after application starts. This makes it useful for quickly testing and developing code. Let's open Spring Data JPA application class. We need to create a bean. Let's create a command line runner. We will define it as public method because all Spring Bean must be public. The method will return a command line runner. The method also requires a parameter. We need to pass the employee repository as a dependency, which allows us to interact with the database. Inside the method, return an arrow function, args, arrow, then curly braces. Inside these curly braces, we will write the code for our database operations. This code will execute automatically when the application starts successfully. To begin, let's save an employee to the database. We will create a new instance of the employee class and set the necessary properties. First name is John, last name Doe, email john@learnwithiftekhar.com. We will also set the hire date using the local date class. It requires 3 parameters, the year, the month, and the day of the month. Let's set the hire date to January 1, 2022. The year is 2022, January is the first month of the year, and the date is 1. Finally, we will set the salary. Let's assume John's salary is $2,000. Our employee object is ready. We will save it to the database using save method from the employee repository. Now, let's start the project. In the console, you'll see the SQL queries printed. This includes an insert statement for the employee table and a query to fetch the next sequence number for generating the ID. Let's verify this in the database. Open our database tool and refresh the employee table. Check the data and you'll see the new entry. The ID is automatically generated using the sequence. The email, first name, last name, salary, and hire date match exactly what we provided. And that's it. We have successfully saved an employee to the database. Now, let me show you something interesting. Stop the application and start it again. Take a look at the console. There is an exception. Let's check what happened. The error message says, duplicate key value violates unique constraint. Employee email unique. What does that mean? Every time we start the application, the command line runner gets executed. This runner is trying to save the same employee to the database. But since we have already saved this employee before and the email field is declared as unique, the database is showing an exception. Let me show you where this is defined. In the employee entity, here is the email field and it's marked as unique through a unique constraint at the top in this table annotation. Because of this, when the application tries to save an employee with the same email address again, the database prevents it and throws an error. As a result, the entry cannot be saved. Now, let's comment out the previous code that was causing the duplicate key exception. Next, we will add a couple of new employees. To do this, we will copy the existing code block and make some changes. First, let's create an employee named Jane. Her first name is Jane. Her last name is Doe. Her email address is jane@learnwithiftekhar.com. Let's assume we hired her in 2023 and her salary is $2,200. Now let's add another employee named Anna. Her first name is Anna. Her last name is Doe. Her email address is anna@learnwithiftekhar.com. We hired her in 2024 and her salary is $1,900. To save those two employees, we will use a handy method provided by Spring Data JPA that allows saving multiple records at once. Let me explain how it works. If we look at the employee repository, it extends from JPA Repository. JPA Repository extends from list CRUD repository, which further extends from CRUD repository. In the CRUD repository, there's a method called save all. This method allows us to save multiple entities in a single call by passing a list of entities. Now back to the code. We'll use the save all method from employee repository and pass the two new employees as a list. Let's start the project. In the console, you can see two insert statements, one for each employee. Finally, let's check the database. Open the employee table. Here you can see the entries for both Jane and Anna have been inserted along with their respective details. Until now, we have saved a couple of employees in our database. Now, let's learn how to query the database in the Spring Boot and retrieve data. First, I will comment out the save operation we wrote earlier. This is important because if we start the application again, it will try to save the same data, causing a unique constant violation exception. The first thing I will show you is how to get the total record count of a database table in Spring Data JPA. The Spring Data JPA provides a method called count, which returns the total number of records present in a table. Let's check it out. We'll use system.out.println to print the total employee count. Number of employee count is, then concat with employee repository.count. Now let's run the project. In the console, you will see a query executed to count the records in the employee table. The total number of employees printed as well. Notice how easy it is to get the result just by using the count method without writing any custom queries. Next, let's retrieve the data of our first employee, John. We'll use the ID to fetch the record. If you remember, John was our first database entry, so his ID is 1. To find an employee by ID, we use find by ID method provided by the employee repository. This method requires the primary key as a parameter. Since our primary key is type of long, we need to pass 1L to represent the ID. The find by ID method returns an optional. If the data exists, we print the employee details. If present or else, inside this we will use an arrow function to handle the result. If the employee data is present, the function will print the employee in the console. If the data is not found, another arrow function will handle this case, printing no employee with ID 1 is found. Now, my IDE is suggesting a refactor. It says the lambda expression can be replaced with a method reference. Let's go ahead and replace it. The method reference makes the code a little cleaner and easier to read. Let's start the application and see the output. In the console, you will see a query to fetch the employee record by ID. It also prints the employee data, but right now it's showing the object reference instead of readable information. Let's fix it. Opening the employee class. Here we need to add a toString method. This method will define how the employee details are displayed when printed. Generate toString, select all and OK. After generating the toString method, let's start the project again. Now closing the employee class tab, run the project. Now you can see the employee data displayed clearly in the console. The first name is John along with the other details like last name, email, hire date and salary. That's how easy it is to query and retrieve data using Spring Data JPA. Now that we have accessed data from the database, it's time to explore the delete method.
Well, deleting an entry from database involves multiple steps. It's a little bit critical than you think. So we'll learn that in the next video. See you there. Bye bye.